Alright. A particle moving in a straight line is x centimeters from the point O at t greater than or equal to 0, where t is this function here. Find its initial position and velocity. Now once again, I'm going to be quite lazy about this, like I always am. I'm just going to lob it all into the table function and figure out exactly what's going on. So I put it all in the table function like so. And it's a cubic function, so it means it has a max and a min, usually. Not always, but usually. And what we can see here, I'll start at 0 and then at 20, just to see what happens. Okay. You go to the left 3, and then you go to the right 11, and then you go back towards the center again. So does everybody understand what those points mean? So what these points here mean is the following. Okay? Alright guys. 0 minus 3 means, see point 0. Minus 3 would mean you're 3 to the left of point 0. Does that make sense? 1 second later, where are you? 11 to the... You're 11 to the right then, aren't you? And after 3 seconds, where are you then? You're back where you started. 3 to the left. Does that make sense? Alright. That's what the question actually means, right? Now, what's its initial position? Alright, initial position would be, initial position is minus 3. We have that from that, don't we? Now, let's get the velocity. What's the velocity formula? First derivative, which is minus 22t plus 24. Charlie, what happens when we replace it in t equals 0? You sub in t equals 0 because you want the velocity. The first derivative is the velocity. You want the velocity at t equals 0. So did everybody get a velocity of 24 meters per second? Anybody get that? Alright. Now, find its velocity at any time. Lads in the corner. Focus. Sorry, not you, obviously. I now figured out what happened. Lads in the corner, can you focus now, please? Alright. Its velocity at any time is the first derivative. Everybody cool with that? The first derivative is its velocity at any time. At what times is the particle stationary? Stationary would mean that its velocity is 0. If its velocity is 0, this implies that the first derivative must be equal to 0. 3 times 24, 72. Two numbers that multiply to give you 72, but add to give you 22. 18 and 4. 3t squared minus 18t minus 4t plus 24 equals 0. Actually, will somebody just give me the answer for that? What is it? 3 and 6? 2 and 6? Alright. Look, I just want to cut down time here. Everybody knows how to solve a quadratic equation. The answers are 2 and 6. And we're back. Okay. Stationary times are t equals 2. Everybody focus, please. That's everybody. T equals 2 and t equals 6. What are the positions of the particles when they're stationary? You go to your calculator. T equals 2 is 9 meters. And t equals 6 was minus 39 meters. So it's 9 and minus 39. Just sub in 2 and 6 into the original formula. How long is the particle's velocity negative? Lads, this is a tough one. How long is the particle's velocity negative? Well, this is actually an inequality. So what we do here is we say that the first derivative is the velocity. The velocity in turn is negative. Alright, so when is it negative? What shape is this graph? U or N? U or N shaped? U shaped, right? So it's U shaped. And you already told me earlier, it crosses at 2 and 6, was it? Cross at 2 and 6. Alright, do you want it above the line? Do you want the yellow region or do you want the blue region? Huh? You want the blue region. So you want your result to be in between 2 and 6. Is that okay? You can verify that in your calculator by looking at this. What's happening between 2 and 6? The y value is getting smaller, isn't it? And then what happens after 6? It turns around and goes back up again. Okay. How long is the particle's velocity negative? Technically 4 seconds, isn't it? So 4 seconds, which is in between 2 and 6. Find its acceleration at any time. How'd you do that, Haymans? Second derivative, and what do we get? 16 minus 22. When is the particle's acceleration 0? No bother, we just solve it equal to 0. Anybody got 22 over 6? Which is what in decimals? Anybody? So 3 and 2/3 basically, isn't it? Now, unfortunately for us, we have to figure out both its position and its velocity, right? Now, the cheap way of doing so essentially you have to sub in 3 and 2/3 into the original formula, and you have to sub 3 and 2/3 into the first derivative. Okay? Now, I can take a shortcut here. I have this ready to go. Oh, it's gone. Never mind. I had it ready to go. Never mind. I just had to plug it all in now. Can you guys do that? Are you guys alright for doing that yourselves? Just subbing in 3 and 2/3 into the derivative formula and the original formula. What did you get anyway? What did you get when you subbed it back in? Anybody? Alright, let's just assume you can do it. The life is amazing right now. Alright. Oh, a useful one. Now, a number of cells grows in time such that your population is equal to n0 e to the point 2t, where n0 is 5. Okay. So why not just put 5 there? Everybody cool with that? Alright. Find the number of cells when t equals 0 and t equals 10. Once again, 5, mode setup, mode calculate, 5 shift e, 0.2 x, start at 0, end at 20. What's happening is the population of the cells is going up. It was at 5, now it's at 7.4 cells, whatever that means. And then after 10, as 10 is it? At 10 we're at 36.94. Then we got 36.94. Now, to me that's 36 complete cells. If that makes sense. So you sub in 0, and what do we have for the first one? 5, and the other one? 36.94, or sorry, 36.95, which to me would be 36 complete cells. You either have all of a cell or you don't. Do you get what I'm saying? It's a bit like a human. You either have all of it or you don't. You either count it or you don't. Okay. What is the average growth rate for this period? Okay. What's 36? Sorry, what's 36 take away 5? Actually, we'll do the full thing. What's 36.95 take away 5? 31 points. And divide that by 10 seconds, and what do you get? An average of 3.195. cells per, is it per second or per minute? Doesn't say. Cells per unit. Fine. Find the instantaneous rate of growth at t equals 5. What does that mean? Find the slope at first derivative at t equals 5. Alright, first derivative at t equals 5. So what do we get here? What happens when you differentiate an e function? What happens? The e stays the same. And what happens to the derivative of the power? 0.2. And what's 0.2 times 5? Pretty sure it's 1. Now, what does it want me to do with the t value? Sub in what? 5. And you get e to the power 1, or otherwise known as 2.718. We good? Alright.